Nope. So the rooftop of a 5-story building is 50 feet above the ground. So we know that, and they give us a good picture here, thankfully, that this is 50 feet up here. How long does it take the water balloon dropped from the rooftop to pass by a 3rd-story window at 24 feet? So this height right here is 24 feet. So the first question is, how far is the water balloon actually falling? 26 feet. Okay. So this equation that they give us says that using the model h of t equals h naught. Remember, h naught stands for our initial height. We're supposed to solve the equation for h of t equals 24. So when you reach the step at which you divide, I don't know, that's just telling you random information. So the balloon is falling 26 feet. This height right here is going to give us how high it is, like, off the ground. So it is going to be 24 feet off the ground is what we are looking for. So thankfully they've told us what to do. What is my initial height here? What is h naught? 50, because that's where we're dropping it from. And then they were nice and told us that h of t equals 24. That's not what I wanted to do. That's what I want. So h of t equals 24. So we're going to rewrite that. So you got some space over here. You can try and use those boxes that I don't like because they're too small and I can't write in them. And I get 24 equals 50 minus 16t squared. And I need to solve this. So how am I going to solve this? What am I going to do? Okay, the very first thing I'm going to do is I'm going to subtract the 50 from both sides. Oh, so much better. And 24 minus 50 is going to give us what? So negative 26 equals negative 16 t squared. And I'm again trying to get t by itself, so I need to get rid of that negative 16. How do I do that? Okay, so I'm going to divide both sides by negative 16. I can reduce 26 over negative 16. Is it going to be positive or negative when I reduce it? So it'll be a positive, and it's going to give me 13 over 8 equals t squared. And then I need to get rid of that square, and that's what we talked about a little bit yesterday when we were solving square roots. How do I undo a square? What do? I find the square root. So I'm going to square root t squared and square root 13 over 8. Okay, I'm out of space, so I'm going to move over here to the right. Thankfully, I can zoom in a whole lot. So I had the square root of, I'm going to write this as the square root of 13 over the square root of 8 equals t, so that I can start manipulating each of those. Can I simplify the square root of 13 at all? Why not? Yes, it is a prime number, so there's no factors in there. There's no way I can find a perfect square that goes into 13. So that I'm not even worried about. It's going to stay my square root of 13. Okay, is 8 factorable? Okay, so you can either list out all the factors of 8, like 1 times 8, 2 times 4, and find the perfect squares. Or you can do the factor tree, whichever one makes more sense to you. I'm going to do the factor tree on this one, which, trust me, it is 2 times 2 times 2. And hopefully you can use common sense and think about that would be 8. When I do it like this, what am I looking for in here? My pairs. So I have a pair of 2's, which means that my answer is going to simplify into square root of 13 over 2 times the square root of 2 for right now. So because there was a pair, I can take the square root of that, which gives me 2 on the outside. Now, what's the only thing wrong with the way this answer is written right now? I have the square root in the denominator, and I cannot have that. So how do I get rid of that? I rationalize. That's exactly, and we've got to remember that word, because that word rationalize is going to come up all school year, the whole year. It's going to come up when we get into square roots in the second semester. It's going to come up when we get into rational numbers. It's going to come up when we get into dividing by imaginary numbers. It's going to continue to pop up over and over and over again. And so we need to make sure we remember that word. So rationalizing means I'm going to multiply by the square root of 2 on top and the square root of 2 on bottom. So what's that going to give me on top? 26. Let me find a different color. Maybe we'll go with maroon. Okay, so I have the square root of 26 on top. On bottom, I have 2 times the square root of 2 times the square root of 2. Well, what happens when I multiply the square root of 2 and the square root of 2? It's the square root of 4, which is really just 2. So I can, if you want to, you can skip and kind of just assume that it's going to be 2 times 2 in the denominator. Okay, some of you need to write this as the square root of 2 times the square root of 4. Because you need to see every step, because that's just how your brain processes it. That is fine. If you need to write that, write that. I'm totally fine with that. Some of you can go ahead and jump and know that really it's the square root of 26 over 2 times 2. And what is 2 times 2? 4. So really my final answer ends up being the square root of 26 over 4. Oh, and don't forget, it is technically the positive and the negative form of that. So that would be my final answer. So we solved this problem. Okay, now what did we actually find? What were we doing? What was it asking us for?
T.
T, which represented my... Yes, my time. Okay, so I got 2 answers for time. I got positive 26 over the square root of 4, and I got negative 26 over the square root of 4. Can I have both of those as possible answers? Time cannot be negative. So I can't have that negative answer. So that's where it says down here, reject the negative value. We ignore that. Okay? We're going to ignore that negative value. And we're only going to focus on the positive value, which was the positive 26 over the square root of 4. And what is that? You have calculators. What is that? You do have those things. Maybe. Maybe not. What number?
It didn't go to a fraction, it's just 1.2.
Yeah, it's a decimal, and it's not going to be a pretty decimal.
1.28 or 1.27 actually.
Okay, 1.27? All right, so that would be our answer, would be 1.27 seconds. So that means after 1 and about 1/4 of a second, the balloon is going to bust on the ground. Okay, or I'm sorry, the balloon is going to hit the 3rd floor, the 24 feet. That's where it was. Okay. So we're going to use this same information for the question on the next page, because if you use here, 24, that's what it told us to use that. Okay, so what did it tell us? And this is based on the way that it's set up. So this is going, when it's telling you to use h of t equals 24, then they're telling us that this h of t represents the height from the ground. The way they have this set up, this h of t is the height from the ground. Not how far it's fallen, how far away it is from the floor. So if I needed thirds, problem 6 on the next page, how long does it take the water balloon described in part B to hit the ground? So if it's hitting the ground, what's the height that we're using this time? What height hit the ground? What am I going to use for my height? Yeah, I'm going to use 0. Because if it's on the ground, then it's how far away from the ground? 0. So that's going to be my formula that I'm going to use this time. Will be 0 equals 50 minus 16 t squared. So you should have ended up with the answer of 5 times the square root of 2 over 4. I've worked it out. This is what it should have looked like when you worked it all out. So kind of some mistakes that I'm seeing people making is you guys are taking the square root of 25 here and you know it's 5, but you write the square root of 5 there. Okay, once you take the square root of 25, it's just 5. That square root symbol is gone. So I'm looking down here at pairs, and that's where I had a pair of 2's because I had that 8, and I factored 8 was 2 times 2 times 2, which we did that on the last one as well. And then another mistake I'm seeing is right here when we add 5 times the square root of 2, we're writing that as the square root of 10. I cannot multiply these numbers together because they are not both inside of a radical. If they are both inside of a radical, yes, I can multiply them and actually get square root of 10. But that 5 is not, so that 5 stays outside, the square root of 2 stays inside, and this ends up being my final answer. Last thing is that technically Because it's a square root and I took square roots, I technically have a positive and a negative answer. But this question is asking about time. And when I'm asking about time, I'm only focused on the positive. So I'm only focused on the 5 square root of 2 divided by 4. And if you put that in the calculator and worked it out, you should have gotten 1.77 seconds. So some of you are getting square root of 50 over 4, and let's talk about that, because there was someone else that got that, and they asked me about it earlier. Okay, if you have the square root of 50 over 4, what that means is you didn't finish simplifying this. So think about 50. 50 is 1 times 25. It is 1 times 50. It is 2 times 25, and it is 5 times 10. And if I look for perfect squares here, I have 1 is a perfect square and 25 is a perfect square. So that means that I can really write the square root of 50 as the square root of 2 times the square root of 25 over 4. Well, can I take the square root of 2? No. Can I take the square root of 25? What is that? So I end up with 5 outside and then my square root of 2 on the inside and 4 on the bottom. So it worked out to be the same answer. If you got that square root of 50 over 4, you just didn't finish the problem. So yes, you should have gotten the same decimal, because when I'm simplifying just means like I'm making it an easier form to recognize. Like if I gave you 100 pennies, do you have the same thing as your friend who has 10 dimes? Yes, you both have $1, right? Your 10 dimes is just a more simplified form of the 100 pennies. That's what we're looking at here, is that when you have this 50, the square root of 50 over 4, that's like, we'll say like your 4 quarters. And then this is like your dollar bill. It's the best you can get it to be. And that's what we're wanting, is that dollar bill form, okay? So on the moon, the distance d in feet that an object falls in time, t in seconds, is modeled by the function d of t equals 8/3 t squared. Suppose an astronaut drops a tool. How long does it take the tool to fall 4 feet? Okay, so I have this equation, and what does it tell me that the d of t represents? No, what does d of t represent? What does it say in words? Yes, it's the distance the object falls in time. So how long is our object falling? No, how long is it falling? How far? 4 feet. Okay, so I'm going to plug in 4 into my equation. So 4 equals 8/3 times t squared. So how am I going to solve this? How do I get rid of that 8/3? I divide by 8 over 3, or I can multiply by what? 3 over 8, because dividing by a fraction is the same thing as multiplying by the reciprocal. And the reciprocal is, I had a really cool math teacher that I worked with at Mesquite. Well, he was kind of weird and a little bit nerdy, but I loved him. He was great. And he would say the reciprocal is the refliprocal. Like, he was really good at taking words and making them sound like what you needed them to do. So like the reciprocal was the refliprocal. So when you need to reciprocate, you refliprocate. You flip the fraction. He was good at puns. Ha. Okay. If you are going to divide by 8/3 here, which that's what most of you are probably going to do. This is one of those times that if you don't use parentheses when you type this in, you will get the wrong answer. Sometimes you get the right answer and sometimes you get the wrong answer. Dividing by fractions is one of those times where you have to use parentheses. If you don't use parentheses, you will get the problem wrong. So what is 4 divided by 8/3 or 4 times 3/8? Either one. 1.5? Okay. So we get 1.5 equals t squared. This makes it easy. How do I solve this? I square root it. So I square root both sides. What is the square root of 1.5? Yeah, that makes sense. Okay, so it's 1.22. And it is always the positive and the negative form of that. But since our answer we're looking for is measured in time, what does that mean about our answers? Do we use both of them? It is just the positive form. So my answer would be the positive t equals, hold on just a second, 1.22 seconds. If you will look at the next page, page 180, this is where we're doing some kind of weird stuff and we're doing something random, but it doesn't make sense to you now, but you need to know it for next time. So that's why we're doing it ahead of time. And in order to understand what we're doing on the next page, you need to understand two things, which you already know one of them. You know that I is equal to the square root of -1. We know that. We talked about that when we have the square root of -1, that is the same thing as I. The next thing you need to know is that I squared equals -1. These are the two two of the three important features of I that you need to memorize, okay? I is the square root of -1, I squared is -1. And I want to show you why, because I think some of you are like, well, how do you know that? Some of you are like, I just trust you and think you're my math teacher and not gonna lie to me.
Yeah.
Okay, so if you have the square root of or if you have I squared, that is really the square root of -1 squared, because I is the square root of -1. And what happens when you square and then you square root something? They cancel each other out. Because a square and a square root are inverses, they undo each other. So when I square and the square root of -1, I'm just left with -1. And that is why I squared equals -1. Yes, ma'am. Problem 9, we need to find the square of the imaginary number. So I'm going to square -2i. If I'm squaring it, that means I'm multiplying it by itself. So -2i times -2i. And I'm not going to FOIL this, because someone in my last class like, well, why aren't you foiling? I only FOIL when there's pluses and minuses in the middle. There's no pluses and minuses here. So I'm just multiplying. So -2 times -2 is what? Yes, +4. And then I have I times I, which is I squared. But I squared is really what? -1. So really this is 4 times -1. And what is 4 times -1? So that would be my answer to this problem. Would be -4. And I am okay if you can jump from this step to this step, I am fine. You do not have to write out this -1 here, because that's an easy process for some people. Some people need to see it because, again, they need to see every single step that they're doing. Other people don't, and that's fine. Let's look back at example B. I have -I square root 2. So I have -I square root of 2 squared, because that's what I'm supposed to do, is square this problem. So I'm going to write it twice. So -I square root 2 times -I square root 2. Well, what is -I times a -I? It's I squared. It would be positive, but it would be I squared because there was 2 of them. And then square root of 2 times square root of 2. Square root of 4, which is 2. Okay, what is I squared? -1, and then that 4 is really a 2. And -1 times 2 is going to give me -2. So see, it worked out to be something pretty. Okay. I'm trying to see time. Okay.